What is that, 62? That doesn't seem right. 9 times 4, 32, 64, 72? Why does that not seem right to me? Is it 72? Yeah, okay, I don't know why that doesn't seem right to me. dv dt equals 72 pi. 72 pi. I need to put my units on this. 72 pi what? Well, time is measured in what? So seconds down here. And then on top, volume. Cubed, right? Cube what cube though? Feet. What was our measurement in here? Feet here? So feet cubed. Had everything been inches, we do inches cubed. So we do feet cubed here for that. Y'all starting to catch on to the idea here? Yes? This will be our last problem, then we'll take a spring break, okay? It's not a circle or a sphere, right? It's something different now, right? So we are now out of our comfort zone a little bit, right? So I can show you the animation. Do y'all want to see the animation, or do you want to try this without the animation first? What do y'all want? Without? With? What do y'all say? With? Who wants to see it first? See it? You want to see it first? Okay, that's enough. So here's a picture of what's happening. This is right here a radar station on the ground, and this is a plane, and the plane is 2 miles off the ground. The plane is flying horizontally, and what we're doing is we're measuring the distance between the plane and the radar station. And at exactly the moment that this distance right here was what, 6 miles, we want to know how fast that distance between them is changing. So here it goes. I'm going to have the plane fly. Here goes the plane flying over, right? And then it goes overhead. So we want to know at exactly the moment that that's 6, at that moment, how fast is that red line between them growing or shrinking, right? We can look at this 2 different ways. There's one point in time where it's 6 miles this way, right? And there's another point in time where it's 6 miles this way. It doesn't matter which one you look at. If we look at the one that's on this side, then you can almost imagine it like you were connected to the plane with a rope, and at exactly the moment that the plane is 6 miles, you're asking how fast the rope is coming out of your hand, which that would hurt, but you get the idea, right? How fast is that distance changing? That's the picture of what's happening. Make sense to you? All right, let's go try and do the problem now. Let's see how my pictures look. So first, my instant in time. All right. So when I do this again, I have a choice of thinking about it as the plane is coming towards the radar station, or it's going away from me. So what would y'all like? Away or towards? Doesn't not matter. You want towards us? Towards? Okay, so here's the ground. Here's my radar station. Thank you. Here's my plane. Can y'all tell what kind of plane that is? An airplane. Yeah. All right, my plane is flying horizontally, right? Now, is there anything in this picture that is fixed, like never changes? The altitude, 2 miles, right? That was given in the problem. That doesn't change. So if I think about this from here to here, that's 2, that is fixed, right? Now the distance between the plane and the radar station, that's this distance right here. That changes, right, as the plane flies. But right now I'm drawing the instant picture. And at the instant we're talking about, we want to know when that distance is what? At the moment the plane is 6 miles from the radar station, right? We mean straight line distance. We don't mean like the shadow of the plane on the ground. When this distance from here to here is 6, right? That's the instant we're talking about. Yeah? That's my first picture. I'm going to start drawing my general picture. In my general picture, I'm not going to be as fancy. I have the radar station and the plane, all right? Now, is anything fixed in this picture? That's still 2, right? I mean, the plane is not losing altitude. It says here, plane is flying horizontally, altitude 2 miles. By the way, we are neglecting the curvature of the Earth. Okay, this is a theoretical flat Earth, which the Earth is flat, right? No. All right, so this is 2, right? That does not change. But this distance between the two, right, that distance between the two, that is changing in my general picture, right? Because the plane is actually moving. So isn't that the thing that we are interested in? We want to know how fast that thing's changing. So that means I should assign a variable to that distance. So what letter would you like me to use? D. So D makes sense because it's a distance, right? I stay away from D for this reason. When I take the derivative, it looks like this, d, and to me that just has always looked weird. So I've not used D, and I don't use capital D because I just don't. I don't know. But if you want, we can do D. Or you want something else? How about H? Like it's almost like a hypotenuse of a triangle. Do y'all see the triangle in here? Yes. Okay, so this is like a hypotenuse. So let's call it H. You call it Z. I would stay away from X or Y. I would reserve X and Y for anything that's like horizontal or vertical. Okay, H, there we go. All right, we've got that so far. Let's not do any more, just for now, because remember I said you don't have to completely finish these. You can kind of like jump back and forth. Let me write down what I'm given and what I want. All right, what am I given? This is the hard one. What am I given? Speed of something, right? I told you all these problems, we're going to have a derivative of something. So what is it? The speed of what? Are we given a speed anywhere? 600 miles per hour. That's the speed of the plane, right? But we need that to be, see, we're given the speed of something with respect to time is 600, right? We're given that. But the speed, it's got to be, this has to be a variable in our picture. What is changing at 600 miles per hour? What is changing? Is that how fast H is changing? No, H is not shrinking at 600 miles per hour, right? Is this shrinking? No, 2 is fixed, right? So what in our picture is changing at 600 miles per hour? The what? The height's not, because remember the height's always 2, right? The plane's position, right? So it's the left and right position that's changing at 600 miles per hour. Right now it's not in our picture. We don't have a variable representing that, do we? I need to assign a variable then. So I want you all to look at this. This is a little tricky. I'm going to draw a right triangle. I'm going to draw it upside down. You wouldn't have to do this. If I draw a right triangle like this, if I call this side X, if I do, then do you agree that if this side doesn't move, okay, the radar station is not moving, the plane's moving. If this doesn't move, then do you agree that X is shrinking? X is shrinking at 600 miles per hour? Because this point's moving at 600 miles per hour, which means that X value is getting smaller at a rate of 600 miles per hour. Yeah? I had to assign that variable x in order for this to work. So I'm going to come back over here and I'm going to put dx dt. See, now I have a variable that's representing this rate of change. And there's one more thing I need to adjust. Because x is not growing, right? X is shrinking. So because it's shrinking, I need to change this not to 600, but to negative 600. Because it's a negative rate of change, right? If x is shrinking, getting smaller, then that has to be negative. If x was getting bigger, then I would leave it as positive. So remember in the beginning of the problem I said, do you want it coming towards us or going away from us? If we would have done the one going away, then this would have been a positive number. Any questions on that? A little different than what we've been doing, yes? What do we want in the problem? Okay, we want to know how fast, what's changing? H, right? We want to know how fast this is changing at exactly the moment that what? What's 6 miles? The what?
Or x.
Is it x? At exactly the moment this distance from here to here is 6, which for us is the letter h, right? So at exactly the moment that h is 6 is when we want to take this snapshot. We have a radar station. We have a plane flying over, right? 2 miles high, that never changes. We want to know how fast this distance is changing. All we know is that that right there is shrinking at negative 600 miles per hour. Questions? Sure? Let's get an equation. Well, we're almost out of time. An equation. Something that connects h to x. Any equation you can come up with, but it needs to be based upon the geometry of the situation we're in. Do you all see it? Can't look here. Here. What's that? Distance between points. I think maybe you don't have to go that, you don't have to try that hard for it. That is a right triangle, yes? And we have a lot of relationships on triangles, don't we? We've got Pythagorean, we've got trig functions. Can you think of any equation that you can get that would connect h and x together? Pythagorean, right? Pythagorean says a squared plus b squared is c squared. So couldn't I say that that squared plus that squared is that squared? Yes? And that is a true equation off this picture. So that is going to be my equation. I'm seeing that x squared plus 2 squared must equal h squared, which is the same as saying x squared plus 4 equals h squared. That is a true equation for that scenario, isn't it? That equation must always be satisfied. It involves x and h. And so when I differentiate it with respect to time, I'm going to get both dx dt and dh dt to pop out of this, won't I? So let's do it. Differentiation time. Implicit is, let's see, what's the derivative of the left side? So what's the derivative of x squared with respect to t? 2x first times dx dt. That's chain rule, right? dx dt. We're done with the derivative of that. Plus, what's the derivative of 4? Well, it's a constant by itself. So derivative of 4 would be 0. Equals, now the derivative of h, which is the same as like we did with x squared. Sorry, derivative of h squared. 2h times this time dh dt. That's our chain rule over there, right? And now a quick check. I'm almost out of time. A quick check. What do we have here? dx dt I'm happy about because I actually know what that is. dh dt I'm happy about because that's what I'm looking for in the problem. Also, I know that h is 6, right? So I know what that is, right? What do I not know? I don't know what x is, right? This is the one I'm not sure about. but I can fix everything in time now. So if I fix everything in time and go back to this picture, isn't this 2, this is 6, and that's x right there? And so you could just use your Pythagorean to get it like this, right? Because now you can fix h to be 6. So we know x squared plus 2 squared is 4 must equal 6 squared, which is 36. And if you solve that, you get x squared is 32. And you take the square root on both sides and you get root 32, only taking the positive answer. See what I've done? And then we go back over here and we plug that in. And then once you do that, you can plug all the things in and you solve. So we're out of time. So over the spring break, what I'd like for you to do for homework is nothing. But I would, if you struggled with chain rule, you struggle with product rule, whatever, you have a whole week to cover things. We will come back, okay? We will come back and I will pick up where we left off, all right? I don't want to have to go through this whole thing again. We're going to start doing harder problems, all right? They're going to get more complicated. The geometry is going to get more complicated. And then we'll be moving on. All right, everyone. Everybody have a good holiday, good spring break, and a safe spring break.